Okay, so this is the video lecture for Math 3, Unit 2, Objective 3. So for this objective, we're going to be looking at solving and graphing absolute value inequalities. So there will be some solving, so you might want to look back at your Objective 2 lesson if you need some kind of review for solving with absolute value equations, because that technique is going to be very similar to what we're going to do. Okay, so let's go over a couple of things here. So the first thing we're going to take a look at is just some situations here. So the important thing that we're looking at is if C is greater than 0. So that would just mean if C is positive, right? So if we have the inequality where C is positive, right? So that just means that C is a positive number. So we'll make sure that we're always paying attention to that part. So the biggest thing that might be important is for you to pay attention to that the absolute value here is isolated. So all of these things that we're getting ready to talk about right here this is when the absolute value is isolated, meaning it's by itself, and then the number is on the other side of the inequality. So your absolute value of x is on the left, and then this could be maybe x plus 2 inside, or something different. But in general, your absolute value is isolated on the left, and then your number is on the right. Okay, and then these two ideas here are essentially the same, and these two ideas here are essentially the same. So we're going to look at these as blocks of 2, noting that the only thing different between this and this is that there is the underline here, which means that it can be also equal. And then here, only less than. So this could be a less than value, but it could also be an equal value. So it could be either one of those two. Okay? So when we have this less than or equal, this is what we call a conjunction. So this is called a conjunction. And when we have a conjunction, then meaning we have that less than, then that means our solution is a combined value, right? So if it's less than, our solution is a combined value, so we'll only have like one shaded region. Okay, so that's one thing we would look at. Whereas if it's greater with either equality, so that underline or not, then that is what we call a disjunction. So disjunction, meaning it's kind of disjointed, is one thing to think about. And so we would have two regions that are shaded. So we would have two sections, okay? So one big idea here is that if we have a conjunction, we have a combined solution, meaning there's only going to be one solution, so one section shaded, okay? Whereas if it's greater than, then we have a disjunction. So we have two sections that we will be shading. Okay, so disjunction, we will have two sections shaded. So whenever it's greater, two sections, less than, combined. Okay. So when we have that combined inequality, then the way we would write our solution, like our final answer, would be, so like right here, the solution here, we would say that x, right? So x is some value between negative c and c, and we're going to use interval notation. So we would say the solution goes from negative c to c, and that's how we would write our answer. So from negative c to positive c, so that's like whatever that value is there, okay? And we would use parentheses because it's an open dot, and it's an open dot meaning we cannot include the number, it's just the numbers between, and we know that because it's strictly less than. Whereas for this answer right here, right, for this answer, we would say it could be equal to negative c all the way to the value of c. So here the difference would be these are closed dots, so it is equal. And if it's closed dots and it's equal, that's because it's allowed to be equal, and that's given by this indicator, right? So the underline there. Okay, so that's how we would write our answer. So our answer would be a combination, right? We would have the graphing component, and then we would also have this inequality, interval notation. And we would have both of those, okay? So the graphing answer on the number line, and then the interval notation. So from negative c to c, negative c to c, okay? Whereas if it's a disjunction, we're going to always have two solutions that look like this. So, and we're going to use interval notation as well, right? So not inequality notation. So we're not doing inequality. We're just going to be doing interval notation. And that's a change from this year compared to years previous. So we're only going to be doing interval notation. So our interval notation here would be for this one, okay? So we would have to have two separate answers because we have two separate highlighted sections. So this answer for interval notation, for example, would be we go from negative infinity, so left to right, until we get to negative c. So that would be one answer. Whereas the other one, so we're going to put a little union symbol. This one right here starts at c and then ends at infinity. Okay, so it would look something like that. Okay, and so two separate intervals, and then we use that little union symbol to say there's two different answers. Okay, so we have two solutions, and when we have two, when we have a disjunction, and we know that we have that greater than symbol. Okay, and then here the answer, so the only thing different between this one and the one above is that there's a closed dot here versus an open dot, and there's a closed dot because of the equal. Okay, so whenever we see that equal, we know we have a closed dot, right, that we're going to be using, versus if there's no equal, then we use that open dot. Okay, so we look right there to determine should there be a closed dot or not. Okay. So this answer would be starting at negative infinity, because we always read left to right, and ending at negative c, and closed bracket, closed dot, so bracket. And then the other section, we go left to right, so we're starting at c with a closed dot, so we use a bracket, and then we go forever to the right, so towards infinity. Okay. All right, so we have, if ever there's that positive number. So we have special cases for if c is greater than 0, oops, sorry, for c greater than 0, that's above here. For c less than 0, this section right here, so that's if c is a negative number. Then we have to treat it differently. So if we have this absolute value of x less than a negative number, and then this is the same idea, right? But it's just this has an equality, whereas this one does not, but the idea is still the same. So here, what we're looking at is we're trying to figure out what absolute value of what number would be smaller than a negative number. And so we know that this portion right here is always positive, right? Always positive. So is there ever a positive number that will be smaller than a negative? And that never can happen, right? That can never happen. So in that case, then this would be no solution, right? Or of course you can use the symbol. So here, so let's take a look at the second one. So we have the same idea. So again, it doesn't matter which case I look at because the equality piece is not going to change it. So here we have an absolute value. And again, we know that c is a negative number from above. So if we have this absolute value, right, and we want to know when will it be greater than a negative number. So again, absolute value is always positive, right? So when will this always positive value, I guess it could be, I shouldn't say always positive, because it could also be 0, right? So even for the 0 case, this would work, which is not a positive number. So let's keep that clear. So this would be, I should say always non-negative, but always positive or 0. So here, so this is either always positive or 0. So what numbers out there are going to be greater than a negative number? Well, that would be all the positive numbers, including 0. So then this is always going to happen, right? So this is always true. So then this would be infinitely many solutions, right? Okay, so that would be infinitely many solutions because you could pick any value, right? You could pick any value and it will always be positive. So there's infinitely many solutions. And if you want to write it as a solution set in interval notation, then you would go from negative infinity to infinity. meaning x can be any value between negative infinity or infinity. And then some people will use the all real numbers, which like that would be good too, right? So maybe something like that. Okay. All right, so let's go ahead and take a look at a few examples here. So for this, we're going to solve just like we did in the last lesson, graphically and algebraically. So we're going to solve both graphically and algebraically. And this time I'm going to flip kind of the order in which we do it so that we can kind of see that. So we're going to actually start with part B instead of part A, just to practice solving that algebraically component. So we're going to do it just like what we did before with our equations. So step 1, so from even objective 2, so if you struggle with objective 2, objective 3 is not going to be any easier, it's going to actually be harder. But if objective 2 ended up being fine, objective 3 will be fine as well. Okay, so step 1. So we're going to look here at our steps to solve algebraically. So we always want to start with isolating the absolute value, right? We always want to isolate the absolute value and get it by itself. So for part B here, it's already isolated, right? So I don't have any numbers outside of the absolute value that I need to move to the other side. So step 1 is already done for us, which is pretty nice. And then step 2, we want to rewrite as a compound inequality unless it is a special case. So when is it a special case again? If the number is negative. Number on the right, yeah? So if I look here, this is a positive number, so that means I need to keep solving, right? So just like before, if this is a positive number, we know we're going to have our 2 solutions, and so then we have to create our 2 equations. So this is just like objective 2. So I'm going to create my 2 equations here. So I'm going to have my positive version. And then I'm going to have my negative version. Right? So this is just like objective 2, at least how we get started. Okay, so then from there, we need to solve each compound inequality, so that's step 3. And this is from previous classes. Whenever you multiply or divide by a negative number, you need to flip the inequality. So whenever we multiply or divide by a negative number, we flip the inequality. Okay, so we need to remember that when we're solving. Okay, so when I go to solve these 2 equations, so I'm going to start with subtracting 3. And so this would give me 0. And then 2 minus 3 is negative 1. And then over here, I want to solve, so I'm going to divide both sides by negative 1 to get rid of that negative instead of distributing, which I could still distribute, like that will work as well. So that gives me a positive number, so x plus 3, and then I divided by a negative number, so we have to make sure, remember to switch the inequality, so that's going to switch this way. And then that will give me negative 2. So 2 divided by negative 1 is negative 2. And then finally subtract 3. And so then I have x is greater than or equal to negative 5. Okay? So if I take a look at setting up my number line, so I have to have both. So I have to have my number line, and then I have to have my interval notation. So I need to have both of those. Okay? So when I set up my number line, so I'm going to just mark 0 here. I usually mark 0, you don't have to, but and then I'm going to mark both my numbers here. So I have negative 1, and then somewhere, wherever, I'm going to mark negative 5. So I'm going to have a closed dot on the negative 1 because of the equal sign, so a closed dot on the negative 1. And I need to be less than or equal to negative 1, so that means I'm going to go to the left here. So I'm just going to go above it so I can see that better. So less than or equal to negative 1, so that would be going to the left. So this is less than. So that means I'm going to go left. Okay? And then here, x is greater than or equal to negative 5. So because of that underline, I'm going to use a closed dot on negative 5. And then I need to be greater than or equal to -5. So this symbol right here is greater than, right? Oops, spell that correctly. So then I'm going to head to the right. So then that is going to go this direction right here. So head to the right. And then my overlapping section, so you see how they overlap. So this section right here is actually my solution, right? That overlapping solution. Okay. So this is one thing that we need to talk about then as well. So then I'm going to kind of backtrack. But so that's just kind of solving that. And then I see that there's an overlapping section. And so that is my shaded solution, right? That graphing piece. So when you take a look at this part up here, so we're going to point this out. So we're going to go back and look at this guy right here. So when I look at this, so because I have a conjunction, right? Conjunction. Then I know that I have to look at the combined solution between the two. And so when I write my equations, it's important for us to use that word and, because we're saying that this has to be true and that has to be true. Like both have to be true. We're looking for kind of that overlapping piece. And that's why I did this example first before I talked about it, is that I'm looking for that overlapping piece. And the reason I knew that is because of the direction of this inequality. So because it's a less than, then what I'm looking at is when is that true and when is this true. So when is x less than or equal to 1 and when is it greater than or equal to -5. And so this right here tells me right at the beginning I'm going to be looking for a combined inequality, meaning something that overlaps, okay, overlaps. Versus if it was the other way, see how it's greater, then I'm looking for or. So like when is it going to be greater than c, or it could be -x greater than c. And so that or statement means it can either be this highlighted section or this highlighted section, and there will be no overlapping. Whereas up here, they do overlap, and we're looking for the solution of when they overlap because both have to be true, okay? So one thing that I do, which is really not mathematical at all, so don't be thinking this is mathematical, it is not at all. So I look at this little symbol right here. Let me get a different color. So I know that this symbol, both of these guys right here, is the less than symbol, right? So that's a less than symbol. And I think of it as less than, and so and, meaning both have to be true, so it's going to be overlapping, less than and. Whereas this symbol right here, so that symbol is my greater, so either or have to be true, so I'll have two sections. So again, totally not mathematical. So less than and overlaps. Great or one or the other, right? Or. Okay. So again, not mathematical. All right, so back to this problem. So I would know as soon as I'm isolated, I have a less than and I better have overlapping, okay? All right, so now that I have my overlapping section, I need to write it in interval notation, right? Because I have to have both answers. So this is part of my answer and then part 2 of my answer. So let me write PT1, so part 1. Part 2 of my answer is that interval notation. So interval notation, so left to right, so I have that overlapping. So it starts at -5 and ends at -1. Closed dots, so I should have brackets for both. And so I should have both of those answers there, okay? All right, so that's how I would solve algebraically. And then let's go ahead and solve graphically. So again, this is just like the previous lesson as well. So we're gonna start with f of x is equal to the absolute value of x plus 3. So I'm going to go ahead and just graph that. So then my start, so alphabetical order, x before y. So I'm going to look at here and find my h and my k. So my start is going to be at -3, and then nothing being added over here, so 0. So again, I'm just going to do opposite, right? Or what would make that 0? However your brain thinks. Okay, so my start is at -3, 0, and then I'm doing linear absolute value. So my slope or my stretch, however you call it, is what am I multiplying by x, and I'm multiplying by 1. So I'm going to make that a rise over run situation. So my start is at -3, 0 with a slope of 1. So I'm going to go up 1 over 1, and I'm going to do that a few times. And then my reflected side is I'm still going to go up 1, but then I'm going to go left 1. So up 1, left 1, and do it a couple more times, just so I'm accurately graphing, right? So there's f of x. And then for my g of x, so g of x is equal to 2. So I'm looking for where y is equal to 2. So this is my y-axis, so I go up to 2, so y equals 2, and then it crosses the y-axis through 2. And then that is g of x. Okay. All right, so then for part A, they're asking us to highlight the portion of f of x, so we're going to highlight along f of x, which is the absolute value graph. So I have to do some highlighting on that, where f of x is less than or equal to g of x. So I want f of x to be less than or equal to g of x. So I need to do some highlighting here, where it is less than or equal to g of x. So meaning below, right? So where is the absolute value graph below that line? And that would be this little section here. And then these would be closed dots because we are equal, okay? And it's hard to do that with a highlighter and pen because it'll just smear. So there's that one, okay? All right, so let's take a look at the next examples. So if you felt pretty good about that problem, you may want to press pause and try number 2. And then push play again and forward to see if you got that little section right. Okay, so let's go ahead and graph first. So I'm going to start with this graph here. So I'm going to have f of x, so that's just the same as y equals. And then my start is going to be at alphabetical order, so x before y. So at +1, and then nothing being added to the y, so at 1, 0. And then my slope or my stretch, and I can call it slope because it's linear, is -3 over 1. So from here I'm going to go down 3 and to the right 1. And then I'm going to do it again. And then go ahead and connect. Not very straight. Okay, close enough there, right? All right, and then I want to reflect and do it to the other side. So I'm still going to go down 3. That part doesn't change, but now I'm going to go left 1, and then I'm going to do it again. Down 3, left 1. There we go. And then label that f of x. Okay, and then I have g of x is equal to 3. So for g of x equaling 3, so I'm going to say, call that it's the same as y equals 3. So I'm going to go along the y-axis to where it's equal to 3. And then I'm going to draw a line that passes through the y-axis at 3, so a horizontal line. And then that is my g of x. Okay. So then for part A, they're asking me to highlight the portion on f of x. So again, I'm going to be highlighting on the absolute value, where f of x is less than or equal to g of x. So where f of x is less than or equal to g of x. So then I'm going to be highlighting everything on there, right? Because it is always below. There's never a section that is above. So this whole section for f of x would be highlighted. And so that would be my highlighted portion on f of x that is below my line g of x. Okay, and then let's go ahead and solve algebraically. So our first step always is to isolate the absolute value, okay? So we have our f of x, so this is our f of x equation. Sorry. That is less than or equal to g of x, and g of x is 3. Okay. So the first thing we want to do is isolate, right? So we don't want to ever do anything with absolute values until it's been isolated. So then the first thing I'm going to do is divide both sides by -3. And then because I divided by a negative, I want to switch the inequality, right? So whenever you divide by a negative, make sure the inequality is switched. Okay, so then now we have to look here and see that this is a negative number. So because this is a negative number, we don't keep solving, right? So this is going to be a special case, right? So we know an absolute value is always going to be either 0 or positive. And I'm just going to write always positive, but it could be 0 as well. So I want to know, okay, so what solution out there for x will always be greater than or equal to a negative number, because I know that's -1. So what numbers out there are going to be greater than or equal to -1? Like all of them or none of them, right? Because we have two situations, right? There's either going to be no solution or there's going to be infinitely many solutions. Okay. So are there any positive numbers out there greater than or equal to -1? And there are a lot of them. So there's infinitely many solutions. So infinitely many. So in interval notation, that would be from -infinity to infinity. Okay. So something that looks like that. Okay, so then now the rest of these are just solving, so we're not going to have to do like this part right here, but we are going to have to do like the number line graphing, right? So we will be doing that, but not this style graphing. Okay, so we want to solve the following inequalities. We want to graph the solution on a number line. So the number line is, you know, like this style right here. Okay. And then write our solution in interval notation. And if there isn't a solution, we have to explain why. Okay, so step 1, isolate the absolute value. So there's nothing outside of the absolute value, so step 1's already done for us. So then now we see that this is a positive number. So if this is a positive number here, then we need two equations that we're going to be working with, right? So positive number, so we have to have two inequality equations to solve. So our first one is going to be that positive version. So just do positive here. And then we're going to have our negative version. And then I'm going to put the word and or here to remind me of my solution. So this is a greater, so this is going to be or. And if it's an or statement, right? So if it's an or statement, then we should have two sections that don't overlap. Two sections that do not overlap. Great or. One or the other, no overlapping. Okay, so now let's go ahead and solve. So I'm going to subtract 6. And then divide by 3. Okay, and then do the same over here. So then I'm going to divide by -1. And then because I divided by a negative, right, whenever I multiply or divide by a negative, I need to switch the inequality. And then subtract 6. And finally, divide by 3. And it's a positive number, so I don't have to switch. Okay? All right, so let's go ahead and graph it on the number line. So I'm going to mark 0. You don't have to, I just do. And then I have 2, so 2, say, is right here. And then it is equal, so close dot. This is a greater than symbol, so greater than meaning head to the right. So greater than head to the right, so that would be this section here. And then mark -6, somewhere over there. So equal, so underlined, so solid dot. And then that is a less than symbol, so head to the left. And so again, because it's or, it's either or, right? There should be no overlapping, and there's not. So then this is the section here that is a solution, and this is a solution there. Okay. All right, and then this double shading that I did, you don't have to do. That's just the way I do it. So if you just shaded the one way, that's fine. Okay. So then now for interval notation, so we have two sections that are separately shaded, so we have to have two intervals. So we're going to start with this one right here. So for this one here, we go left to right. So we have, so it's part one answer is the shading, so part two answer, so this first interval here. So it goes forever to the left, and then stops at -6, and then not equal to infinity, but close dot here, so bracket. And then the other interval, so this guy over here, so left to right, so starts at the 2, and then goes forever to the right, ends at infinity. And then bracket on the 2, okay? So make sure you have both of those answers there, okay? And again, how do we know that we should have two separate sections? Is because we have that greater or, meaning one or the other, nothing overlaps. All right, let's go ahead and take a look at question number 4. So this is a composition problem. So this is a review off of last chapter and then also last lesson as well. So we have two separate functions, and we know we need to merge them together somehow, right? We have to merge them together, and we do it by replacement because it's composition. So we're going to merge them by replacement. So we know f of x has to go into g of x, right? So f of x, the right function, goes into g of x, the left function. So here's f of x. And it needs to substitute into g of x, right? Because we have to merge those two equations. So we make room for it by kicking the x out and replacing it with 2x minus 1. So then in my equation, I have -1/3, right? And then now merge these two together. So this will turn into absolute value of 2x minus 1. And then I still have a -1 here, and then less than 4. And then now I have to isolate the absolute value before I can do anything else. So we're going to add 1 to both sides. So we're going to do that reverse order of operations, right? Reverse order. So that will turn into 0. And then 4 plus 1. And then I want to multiply by the reciprocal, right? So I want to get rid of the -1/3. So I'm going to multiply by the reciprocal. So -3/1. So this will be 3 divided by 3, which is just 1, so that just cancels. And so then we have absolute value of 2x minus 1. And then I multiply by a negative, so I have to switch the inequality, right? So whenever you multiply or divide by a negative, don't forget to switch the inequality. And then 5 times -3 is -15. So then this is a negative number, so that means it's going to be a special case, right? Special case. So this is just like example number 2, right? So this right here is always going to be positive because it's absolute value, right? So what positive numbers out there are going to be greater than -15? Well, that would be all of them, right? So there's going to be infinitely many solutions. And so if we had to do a number line graph, because they're asking us to do that, so infinitely many solutions, so we mark 0. So that means everything, right? Everything would be shaded. So it would look something like that. And then our solution would be everywhere from -infinity to positive infinity, and that would be our interval solution, okay? Our interval notation. Okay, and then 5 and 6. So if you haven't pressed pause and tried any of these, you should be doing that now at some point, right? So you should press pause, try 5 and 6, and then zoom or fast forward and kind of see if you got the same answer as I did, and kind of see where you're at from there. Okay, so let's go ahead and do these. So for this one right here, so the absolute value is already isolated. So then I just need to set up my 2 equations because this is a positive number, right? So because this is a positive number, I'm going to set up my 2 equations because it's already isolated, right? So I would have 2 minus x over 3 less than 4. And then my other one would be the negative version of that. And then because this is less than, right, less than, then this would be and. So if it's an and statement, there should be overlapping, and we should have that combined inequality. So and, like this has to be true, and this has to be true, so there should be a combined thing. Okay, so let's go ahead and solve. So the first thing I'm going to do is get rid of this divide by 3, because it's, you know, for all of them, right, because the whole thing is divided by 3. So then I'm going to multiply both sides by 3. Three times 4 is 12. And then I want to subtract 2. And then divide by -1. So I just divided by a negative, so whenever I divide by a negative, I want to switch that inequality. So x is greater than -10. And then solve this side here as well. So if you haven't already, you should probably press pause and try to solve that on your own. And then forward to check your answer. Okay, so I'm going to get rid of that negative first. So I'm going to divide both sides by -1. Because I just divided by a negative, I want to switch the inequality. And then I'm going to get rid of the divide by 3. So I'm going to multiply both sides by 3. And then I want to subtract 2. And then divide by -1. So then now I'm going to go ahead and graph. Then I'm going to mark 0. Not because I have to, I just do. And then -10 is somewhere over here. It's going to be an open dot, right? Open dot because it's not equal. And then this is greater than, so greater than means to the right. And then I'm going to mark 14. Open dot because it's not underlined. Less than, so that's a less than symbol, so I want to go to the left. And there should be overlapping, right, because it's an and statement. And I knew that because it was less than. So where does it overlap? It overlaps right here. So this is the section I'm going to shade. And so that's part 1 of my answer. So part 2 is an interval. So I should only have one solution, right? One little section. So that's this part right here. So I go left to right. So at -10, and I'm going to use a parentheses because it's an open dot because it was not underlined, right? So the inequality was not underlined. And then it stops at 14 and then parentheses, okay? So one thing here that I'm going to point out, because sometimes students have a hard time with which way to shade and all that, is if you take a look at, you know, this arrow right here, right? So that arrow is like an arrowhead pointed to the right. So that's why at the -10 I went to the right, because it's like an arrowhead saying, oh, go to the right, if that's helpful. So same thing here. If I look at this guy right here, if I think of that as an arrowhead, it's pointed left, right? That's an arrowhead pointed left. So on the 14 I went to the left. So maybe that would be helpful for you. Okay, last one, number 6 here. So for this one, so always our first step is to isolate the absolute value. So we want to make sure we get that by itself. So the first thing I want to do is add 2. And then I have the absolute value isolated, and then I see that that is a negative number. So because it is a negative number, then that means I don't keep solving. I have to come up with a solution right away. So the way, again, I look at this is I know that this is always positive, right? Absolute values, or 0, right? So always positive or 0. So I'm trying to think of what are the positive numbers out there, including 0, that are smaller than -8. So what positive number out there is smaller than a negative number? And that would be none of them, right? None of them. So this would be no solution, right? So this would be no solution. And there's no way for us to write that in interval notation, so we can't. And then as far as graphing goes, if we felt like the need to graph, on a number line, we would mark 0 and we would shade nothing because there is no solution. Okay? All right, and that's it for this lesson.